Hello, my name is Liang. I'm going to present CSC 575 workshop number 2 today. So the task is given a matrix M of integers and an integer value V. We need to figure out if there is a submatrix, square, or rectangle within M whose values add up to V. Note the matrix M may be a rectangle. Integers may be any integer, positives, negatives, and zeros. You must consider single cell size 1 matrices within M in addition to larger size up to maximum allowable for that matrix. So the matrix size M times N, and could be single cell or strip or rectangles, square, up to the biggest one. The goal is designing an algorithm. The main function need to be Boolean check matrix. We'll take a 2D integer array M and integer V. If the submatrix with some value V found will return true, otherwise return false. The time complexity of the solution must be better than the brute force solution. I started to look at brute force solution. The basic idea is iterating all rectangles through the whole matrix and calculate the sum of each of them. So M is the length of the rows, N is the length of the columns. Iterate all submatrices. For x1, x2, y1, y2 are the four corners of the submatrix. But x1 equal to 0 to M, y1 from 0 to N, x2 from x1 to M, y2 from y1 to N. So these are iterate through the whole matrix. Then we'll get sum of each submatrix. We started sum from 0. For int I equals to x1 and less than x2, I plus plus. For int j equals to y1, j less than y2, j plus plus. Then we added mij to the sum. If sum equals to v, we'll return true. Otherwise, we'll go back to the next iteration. At the end, we'll return false if nothing found. If we look at the worst case of this solution, iterate all submatrix, this 4 levels nested loop, horizontally combination of choose 2 from M, which is x1 and x2, plus choose 1 from M. This is single cell times N, because there's like N rows. The same idea for the vertical side y1 and y2. Then I simplified it, got all of M square N square for this loop. Then for each of the submatrix, x2 minus x1 plus 1 times y2 minus y1 plus 1. So I got all of Mn. Then we multiple this one and this one for the overall time complexity of brute force solution will be all of M cubic N cubic. Then this is overview of my algorithm. Firstly, I'll introduce base strip and the base rectangles. I'll use this concept of base strip and the base rectangle to help to build my algorithm. Base horizontal strip is horizontal single cell strip starting from index 0, like this. Base vertical strip, a vertical single cell strip starting from index 0, like this. Base rectangle is rectangle or square with top left corner at M00. So any rectangle started from here and go anywhere. The reason why I introduced the base rectangle is because I found for any regular rectangle within the matrix, the sum could be calculated by 4 base rectangles. So if you want to calculate the sum of this one, you can calculate it this one minus this one minus this one plus this one. So this way, we can reduce the calculation of all rectangles to just the base rectangles. And if we store some of base rectangles, we can reuse them. Now build a new matrix to store some of base rectangles. I created a new matrix called P to store all the sum of the base rectangles. So P will be the same size with the original matrix M. Each cell of P will store the sum of base rectangles with right bottom corner in that cell. So in P, this cell will store the value of sum of this one. So if I want to calculate the rectangle like this, I'll just need take this cell plus this cell minus this cell, and then minus this cell. Then the next problem is how to build this matrix P, how to calculate the value of each cell. We can definitely iterate each of them and do a 2-level for loop to add each cell together. But this way, there will be a lot of repeat work. To calculate PMN, we'll need to take PM-1 and N-1, which has already done and filled in matrix. It takes just constant time to reuse it. Then take this one and plus this vertical base strip and this horizontal base strip. So if we keep doing this, finally the leftover will be either a vertical strip or a horizontal strip, depending on your rectangle, which side is longer. Because the sum of a base strip will be linear, so this overall calculation will be linear. It's better than 2-level for loop, which will take squared of time. This is a quick summary before I jump into the real code. So first, I'll have 2 base strip functions, one horizontal and one vertical. Take in coordinate x and y, return sum of the base strip, either horizontal or vertical. Then I'll have a build some matrix function, take an existing matrix M, and create a new matrix P with the same size of M to store some of the base rectangles. Then I'll calculate PXY, then return P. The next function will be sum rec to calculate any regular rectangle. This function will take a existing matrix M, then an integer x1, x2, y1, and y2, which are 4 corners of the rectangle, and take this matrix P, return sum of the regular rectangle. This is where we use dynamic programming to reuse the stored pxy from this one. Finally, the main function, nested loop to iterate some matrix through the matrix to get sum by calling this one. If sum of the submatrix equal to V, will return true, otherwise will return false. Here are my code. Calculate horizontal strip, base strip. Int sum equal to 0. For int I equal to 0, I less than x, I plus plus, sum plus equal to miy, return sum. For the vertical, it's going to be similar. Build some matrix. M is length of matrix M. N is a column length. Sorry, M is a row's length. N is column's length. Then create a new matrix P with the same size of M, which is M times N. Then fill the first row. For I equals to 1, I less than M, I plus plus, then Pi 0 equals to Pi minus 1, 0 plus M I 0. Then we'll fill the first columns. For int I equals to 1, I minus N, I plus plus, P0 I equals to P0, I minus 1 plus my M0 I. So now we got this columns and this row and this column. Sorry. Then we'll fill the rest of the matrix. For each of them, I from 1 to M, J from I to N, Pij equals to Pi plus I minus 1, J minus 1, plus this base strip vertical 1, this one, and plus this base strip horizontal 1, like this, return P. Now let's look at sum of any rectangles. Sum rec will take existing matrix M and a rectangle you want to calculate by x1, x2, y1, y2, 4 coordinates, and the matrix P we just got from previous step. If x1 equal to 0 and y1 equals to 0, so the rectangle will be like this. Just return this cell px2, y2. Else if x1 equals to 0, so it's like this. We'll return px2, y2 minus px2, y1 minus 1. So it's going to be this big one minus this smaller one. We got this. Else if y1 equals to 0, so I'll talk about something like this. We'll use the big one minus this one. So we'll return px2, y2 minus px1 minus 1 and y2. Otherwise, for this just a regular one, we'll return px2, y2 minus px2, y1 minus 1 minus px1 minus 1, y2, and plus this one, px1 minus 1, y1 minus 1. Finally, the main function, check matrix. M is the M dot length, and is M0 dot length. Firstly, we get sum of the base rectangle matrix P by calling the previous function build sum matrix M. Then we iterate through all submatrix. For x1 from 0 to m, y1 from 0 to n, x2 from x1 to m, y2 from y1 to n. Then we get sum of each rectangles by calling this sumRec function. If this one equals to v, we return true. Otherwise, go back to next loop. Then after the whole thing iterated, nothing found will return false. Now let's look at the time complexity of this solution. Let's look at auxiliary functions. So all four auxiliary functions are the same for all cases. The difference will be on the main functions. Now let's look at the time complexity of this solution. All four auxiliary functions are the same for all cases. I'm sorry. The difference will be on the main function. The horizontal base strip function is linear iteration, will loop x times 0 less than x and less than m. So it takes all of m. The vertical base strip function is also linear iteration, will loop y times y larger than 0, y is between 0 and n. So it takes all of n. Build sum matrix function, fill in the first row loop m times, so take all of m. Fill in the first column loop n times, so it takes all of n. And this nested loop iterate m minus 1 times n minus 1 times. It's all of mn. Then each iteration will be all of 1 plus this base vertical strip is all of m, and this base horizontal strip is all of n. So the total is going to be the loop times multiply each iteration. Simplified it, then the overall total is all of m square n plus mn square. This sumRec function for the just regular rectangle, just take one value from the matrix P, so it is all of 1. For the main function, this build sum matrix is m square n plus mn square, we talked about already. And this loops for the worst case is happens when no match value found. So the whole loop will iterate completely. Total loops m times n times m minus x1 times n minus y1. It's all of m square n square. and each of them, each iteration will take all of 1. So for the worst case, this 4-level nested loop will dominate the overall complexity of the solution. It's going to be m squared, n squared. Remember, we talk about brute force solution. Worst case overall time complexity is all of m cubic and cubic. So now we made some improvement from that. The time complexity for the best case. The best case happens when P00 equals to V. So we found the value V at the fourth single cell P00. So this is the same. For this one, is just not happen at all, just all of 1 constant. This is all of 1. So the overall best case time complexity is going to be omega m squared n plus mn squared. The brute force algorithm might have better best case time complexity because it doesn't have any pre-function. But since the best case happens really rare, this algorithm will get much better on the average time complexity. The space complexity for the worst case. These two base strip function, because we just need to keep updating the sum value, so it's going to be take just all of 1. This built new sum matrix function, because we calculate each cell of the new matrix and store it. So we'll take all of mn space to store the new matrix P. Sum rec function simply take and return 1 value from matrix P. So it's just all of 1. The main function build matrix P is all of mn. Sum of each submatrix takes all of 1. So this space can be reused for every loop. So the overall worst case space complexity will be all of mn. Practice using loop environment method, loop 1 and 2. Loop 1 is this one, the horizontal base strip. Initialization, sum equals to 0 is true before the loop runs. Maintenance, each iteration updates the value of sum. If after iteration I, sum equals to s is true, the next iteration I plus 1, sum will be updated to s plus m I plus 1 y is still true. The termination, the loop will terminate after y times iteration when I reach y minus 1, and the sum got updated y times. The loop 2 is similar to loop 1, just vertically. Loop 3 and 4 are also similar. This is the loop to fill in the first row of the matrix P. This is the first columns of matrix P. Initialization, P00 equals to M00 is true before the loop runs. Maintenance, each iteration will fill 1 cell. If after iteration I, Pi0 is true, the next iteration I plus 1, Pi plus 1, 0 will be filled with Pi0 plus M I plus 1, 0 will still be true. Termination, the loop will terminate after m minus 1 times iteration. When I reach m minus 1, and all row P0 will be filled. The similar idea for the loop 4. Loop 5 is this loop to build a regular rectangle for the matrix. Initialization. Row px0 and column p0y are filled and true before the loop runs. This is from the previous loop 3 and 4. Maintenance. Each iteration will fill one cell. If after iteration I equals to x and j equals to y, pij is true. All cells before pij, which means I less than x or I equals to x and j less than y have been filled. The next iteration, I equals to x and j equals to y plus 1, pij plus 1 will be filled with pi minus 1j plus some base strip word mxy and plus some base strip word mxy plus 1. We have proved function some base strip word and function some base strip word are correct from loop 1 and 2. So after iteration I equals to x and j equals to y plus 1, the loop is still true. Termination. The loop will terminate after n minus 2 times n minus 2 times iteration. When I reach n minus 1 and j reaches n minus 1, and all matrix P will be filled. Loop 6. Loop 6 is this 4-level nested loop. Initialization, sum equals to 0 is true before the loop runs. Maintenance, each iteration check one cell's value with V. If after iteration to check value of x1, y1, x2, y2, the result is not matched, the next iteration will be x1, y1, x2, y2 plus 1, or x1, y1, x2 plus 1, y1, if y2 has reached the max number n minus 1. Termination. The loop will terminate if value match found, or all iterations finished, no match value found. Okay, this is my algorithm for this problem workshop 2. Thanks for listening, and please let me know if you have any questions.